Okay, welcome back to Mr. Hassan's Maths channel. This is question number 7 from the International A-Level Edexcel Pure Mathematics P4 paper from January 2021. And this question here, we have to prove that sine 2x over cosine x plus cosine 2x over sine x is identical to cosine x. And x cannot be a multiple of pi over 2, and n must be, and n is an element of the integers, this n here. Okay, so now, to prove something like this, there's a few things that we see here. One of them is that I've got here double angles for sine x and cosine 2x. That's one thing I see. The second thing I see is this is one term and this is two separate terms. So, I mean, I have no idea how I'm going to end up with this. I know it's not much because it's worth 3 marks, not too many marks. But those are two things that I can see. I want to end up with a single angle and I want to end up with one term. Here I have double angles and I have two separate terms. The other thing is cosec x is 1 over sine x. 1 over sine x. Okay, so I'm going to write this. I think of this as 1 over sine x. All right, so that's the other thing that I know. Okay, so that's going to be like you have to have kind of sine x underneath kind of thing. So anyway, so first of all, what I'm going to do is I'm going to write this as one fraction. So I'm going to multiply both top and bottom by sine x, and in that case I'm going to get sine x times cosine x, and I'll have sine x times sine 2x. Okay, so sine x times sine 2x plus, and here I'm going to multiply both top and bottom by cosine x, and I'll end up with cosine 2x times cosine x. Okay, now, so I've made one term. The other thing is the double angles. Now, I have some identities that we know, that we have to know, these identities, and one of them is sine 2x equals 2 sine x cosine x. These are called the double angle identities. Okay, the double angle formula, you can say. So I know to replace sine 2x with 2 sine x cosine x. So let me just do that. That's 2 times sine x times cosine x times another sine x. Plus, now for cosine 2x, there's a few different identities. The main one is cosine squared x minus sine squared x. Now both of these are based upon the factor formulae, which you can find in in the formula book, right? They're both based upon the addition formula, actually they're called. So cosine 2x equals cosine squared x minus sine squared x. Now from this I can derive two other identities. One of them is basically, if I change this into 1 minus, I know that the main identity we learned from P2 was sine squared x plus cosine squared x equals 1. So cosine squared x would be 1 minus sine squared x. So I could write this as 1 minus sine squared x minus another sine squared x, which is 1 minus 2 sine squared x. Or I could even write this as, if I change the sine squared x for 1 minus cosine squared x, then I have cosine squared x minus 1 minus cosine squared x, which will give me 2 cosine squared x minus 1. So these identities, we should really know them. They're not in the formula book. You can derive them from the formula book, but once you got used to them, you'll be able to know these identities. For cosine 2x, there's 3 forms we could write. For sine 2x, there's this one form. Okay, right now, what I'm going to do is, because I've got cosine x here and cosine 2x. Okay, so what I'm going to do is, if I write this as, let's have a look. This is going to be 2 times, this will be cosine times sine squared x. So I think I will write this as 1 minus 2 sine squared x, because then I think I'll have a like term with these, maybe. Let's have a look. Because I'm going to have sine squared x times cosine x, I'm going to have sine squared x times cosine x. That might get rid of something. You see, I'm trying to figure out how I'm going to simplify this, you see. So I'm thinking that this is going to end up being sine squared x, 2 sine squared x cosine x. And if I change it to 1 minus 2 sine squared x, instead of 2 cosine squared x minus 1, I will also have a minus 2 sine squared x cosine x, and I think they will cancel out. So that will help me to simplify this. So that's So you can kind of like see some sort of way appearing for us out of the, the darkness here, not knowing where it's going to lead to. We're using some kind of educated type of guessing here to find out what way to go. So as I said, this one, if I just simplify that, that's 2 sine squared x cosine x, and this is going to be plus cosine x minus 2 sine squared x cosine x, and I think that worked, didn't it? I can see the way now, I think, because then I've got sine x times cosine x underneath. Now these cancel each other out. 2 sine squared x cosine x minus 2 sine squared x cosine x becomes 0, and I'm left with just this, which is cosine x over sine x times cosine x, which cancel out. I'm left with 1 over sine x, which is equal to cosec x. So we've got there. We got to where we wanted to get to. All right, so again, I had no idea when I started how this is going to work out, and this is how these questions normally work. You just think a few logical steps. So I'm thinking that I have to reduce these to single angles because in the answer there's a single angle. So I have to find a way to make these, use these identities to reduce them to single angles. The other thing I was thinking is that these are 2 separate terms and this is 1 term. So let's combine these 2 fractions together into 1. And then we had to make a little decision at this point. What shall I do with the cosine 2x? Shall I make it 1 minus 2 sine squared x, or shall I make it 2 cosine squared minus 2 cosine squared x minus 1? And we saw that if I had made it 2 cosine squared x minus 1, we would have got like cosine cubed x here, and it would look really complicated. We could probably still get to the destination in the end somehow by doing some more modifications later. However, seeing 1 minus 2 sine squared x, that kind of like, all right, that's going to give me minus 2 sine squared x cosine x. I'm going to have 2 sine squared x cosine x. That will help me to get rid of these 2 terms and make it simpler like it's supposed to be at the end. So there we have the answer to 7 part A. Okay, I hope that was clear. These questions are all like that. You start blindly. You start without being able to see the path, how to get to the goal. You know what the goal is, but you don't keep looking at the goal and thinking, how am I going to get there? You think step by step. You think, what can I do? Think just logic. Think, okay, what can I do to make this more like that? All right, get rid of the double angles, make it into 1 fraction, and then you see it works out. Okay, it will always work out. There's always going to be a way for you to get from here to here, because that's why they gave you the question. Right, so don't ever just think, oh, it's not impossible. It's not impossible. It's possible. You have to just take a few logical, clear thinking steps, and you'll get there in the end. Okay, so that's the answer for 7 part A. Now for 7 part B. Okay, it says hence solve for minus pi to pi, so minus pi over 2 up to pi over 2 for theta, this equation. Okay, I think I need, because it says hence I need the result from the last page. Let me just get that over here. Okay, I've just put the result up here. Okay, that's the result that we got from the last page. Sine 2x over cosine x plus cosine 2x over sine x equals cosec x. So we got to solve for this range, this equation. So if I look at these, I kind of see some sort of a similarity between this part and this part. Okay, this is the sine of double of an angle over cosine of of the angle, and this is cosine of double of the angle over the sine of the angle. This is the sine of the double of this angle over the cosine of this angle 2 theta. So this 4 theta is double 2 theta. So what we could say is, what they've done is they've taken the x and they've replaced it with 2 theta. That's what they've done. All right. So that's what we can do here. We can say that the x has been replaced by 2 theta. So I can say that 7 plus sine 4 theta over cosine 2 theta plus cosine of 4 theta over the sine of 2 theta equals 3 cot squared 2 theta. I can say that this part of it can be replaced, this part of it here can be replaced by cosec 2 theta. So 7 plus cosec 2 theta is equal to 3 cot squared 2 theta. So all of this part is replaced by cosec 2 theta because x in our identity that we found here, that we proved here, the x, you can see this is like the x has been replaced by 2 theta. So I got to replace this x by 2 theta as well. So that means all of this is going to equal cosec of 2 theta. All of this equals cosec of 2 theta. Now I can use identities to sort out this problem and solve this like a quadratic. I want to make them the same in terms of the same ratio. Now there's two ways you can go about this. I'll show you both ways. One way is to use them as reciprocal functions, and I know that sine squared theta plus cosine squared theta equals 1. Now many people, they only memorize this identity, and from this they derive all the other identities that we need, and that's something that I normally do. I don't have all these different things stuck in my head. I normally just memorize this identity, and then when you're getting close to the exams or whatever and you practice a lot, you'll understand what they are like. All right, you'll understand exactly what the other identities are. Okay, so what we have to do is we have to think about, we want to have an identity. I want to make the one that's squared into the one that is not squared. Okay, so I'll just write this as, just to make it different, sine squared a plus cosine squared a equals 1. So I want to change the cot squared 2 theta into something involving cosec squared 2 theta. Okay, so what I'm going to do is I want to have cosec squared in my form, so I'll divide this by sine squared a, divide this by sine squared a, and divide this by sine squared a. Divide every term by sine squared a. This will give me 1 plus, now cosine squared a over sine squared a is tan squared a, and 1 over sine squared a is equal to, sorry, this is not tan squared a, this is cot squared a. Cosine squared a over sine squared a is cot squared a, the reciprocal of tan squared a, and 1 over sine squared a is cosec squared a. So I know that cot squared a is the same as cosec squared a minus 1. Therefore, cot squared 2 theta is going to be cosec squared 2 theta minus 1. So I can say 7, let me just put a line here to make that separate, 7 plus cosec 2 theta is equal to 3 times cosec squared 2 theta minus 1. Just using this identity here, and now I can see I've got only cosecs in the equation, so I can simplify this and make this into like a quadratic. It looks like a quadratic in cosec. So this is 3 cosec squared 2 theta, be careful here, cosec squared, and then 2 theta minus 3. So I'm going to bring all the cosecs, everything on this side. So I'll put 0 here. I'll keep this term positive. So 3 cosec squared 2 theta minus cosec 2 theta. And you have minus 3 minus 7, which is minus 10. So I end up with this quadratic equation, 3 cosec squared 2 theta minus cosec 2 theta minus 10 equals 0. Now to make life easier, so I don't have to keep writing cosec, what I'm going to do is I say let, for example, b equal cosec theta. So this will become like 3b squared minus b minus 10 equals 0. So now I can factorize this, and I'm going to use my little window method, which I like to use. All right, so I'm going to have here I'm going to have 3b squared, and here I'm going to have minus 10. I need two numbers whose product is minus 30b squared and whose sum is minus 1b. So it looks like 5 and 6, isn't it? 5 times 6 is 30. So one of them has to be positive and one of them has to be negative. It looks like the 6 is a negative, so minus 6b and plus 5b. Okay, I can take out the common factor from these two, which is 3b. 3b times b is 3b squared. 3b times minus 2, is minus 6b. 3b times minus 2 is minus 6b. That should be minus 2 here. And then b times plus 5 is going to give me 5b. Minus 2 times plus 5 is minus 10. It looks like we got the right thing. So this is 3b plus 5 times b minus 2 equals 0. So I can say b is equal to minus 5 over 3. Let me simplify that, make it look a bit simpler. Minus 5 over 3, and b is equal to 2. So now I can say cosec theta, that b equals cosec 2 theta, sorry. Cosec 2 theta. So we have cosec 2 theta here. I should have said cosec 2 theta in the beginning, by the way. So we know that cosec of 2 theta is equal to minus 5 over 3, and cosec of 2 theta equals 2. Right, now I can try to solve these. Now I'm going to use the fact that this is the reciprocal of sine. So if cosec 2 theta equals minus 5 over 3, then the reciprocal of cosec 2 theta is sine 2 theta will be minus 3 over 5. And similarly, the sine of 2 theta here is going to be a half, 1 over 2. The reciprocal of this is equal to the reciprocal of that. That makes it more familiar. Now we have our limits. The limits are theta between minus pi over 2 and pi over 2. So we have theta between minus pi over 2 and pi over 2. Now we don't have theta in our equations here. We have 2 theta. So this must change to 2 theta. So 2 theta, you have to multiply both sides by 2. So 2 times pi over 2 is pi, and 2 times minus pi over 2 is minus pi. So I have to catch all the solutions between minus pi and pi for these two values. Okay, so I need to find, let me find the first solution by using my calculator for this one. So I'm going to say inverse. Now I need to be in what mode? Of course, radian mode. I'm in radian mode, so I'm going to do inverse sine of minus 3 over 5, and that gives me an angle of minus 0.643. Okay, so I've got 2 theta equals, what I'm going to do, because I always have this problem here. Okay, so I've got 2 theta equals minus 0.6435. How many decimal places do they want in the end? 3SF. Okay, so I'll leave it to more than 3SF. Okay, and then round it in the end. That's 2 theta. That's one solution. Now, is it a solution? How can I tell? I can go up to minus pi. So this is way within minus pi. Minus pi is minus 3.142. Okay, so this is okay as one solution. Now, the other solutions are found for sine by doing 180 minus this answer. So it's going to be pi minus this will be pi plus this. Okay, now I know that's going to be outside of my range. So if I do pi minus the answer, I'm going to be more than 3.142. I'm going to get, the other answer is going to be 3.78509. 3.78509. Now this is outside of my range. This is okay, it's inside my range. This is outside my range. But I'm going to use these solutions to find, or try to find, other solutions within my range. Because what we have here, if we think about it, we have the sine curve. Let me try to make that straight. We have the sine curve, say that's 0. It goes like this. And on this side it goes like that. Okay, now we're limited between these values of pi and minus pi. What we got when we did inverse sine of minus 3 over 5, we got this answer over here. This is the answer we got. This is this first answer here, right? The other answer we got was this answer over here. This is outside of our range because we can only go up to pi. But I can see there's another angle here which is going to be inside our range, which is 360 less than this angle. Because these two are the main two angles, and after these two angles, everything else is 360 away from it. So this is 360 away from there, outside of the range, of course. But this is 360 before this. It's in the same relative position. See, they're separated by 360 degrees because it repeats every 360 degrees. So this angle is repeated before 360 degrees before this, which is 2 pi. So if I take this angle, which is outside my range, 3.78509, and I subtract from it 2 pi, I will get this angle, which should be within our range. So if I do that, and I say take away 2 times pi. It will give me minus 2.49. This is minus 2.49809. So that's minus 2.49809. Okay. Yep, that's it. So that is within our range, because minus pi is minus 3.142. So this is in our range. So our two angles in our range are this angle and this angle. Okay, those are from this answer here. Okay, do I have space down here? Not really. Anyway, so those are the two solutions from this section here. Now we're going to find for sine 2 theta equals a half. The first angle is from the calculator, and we know that the inverse sine of a half gives us 30 degrees, which is pi over 6. Okay, so that's pi over 6. And now, does it give that? I think it says all of them 3SF. Where appropriate. Okay, so I don't need to put this to 3SF because it says where appropriate. It's appropriate for this one because it doesn't give you something in terms of pi. This one is not appropriate. You can leave it in terms of pi because it's one of those exact pi values here. So pi over 6. So 2 theta equals pi over 6. That's one of the solutions. Okay, so far I haven't got my final answers, by the way. These are all 2 thetas so far. Okay, so it's just the answers that I'm going to keep out of these. In the end, I'm going to find the final answer, and I'll show you what to do. This is not the final answers. This is just this. Before we get to the final step, I found these 2 answers that are acceptable in our range, but we didn't finish yet. Now, what we've just found is this angle over here. All right, there's another angle which is over here, which is less than 180, less than pi, which shares the same sine ratio as that, and as I mentioned before, that's going to be equal to pi minus pi over 6. That's like 6 pi over 6 minus 1 pi over 6, so that's 5 pi over 6. Now, all the other angles are going to be outside of the range, this way and that way. So if I take away 360 from this, or pi from this, I'll end up over here, out of my range. If I take away 2 pi from this, I'm going to be over here somewhere outside of the range. So these are the 2 angles that are in our range from this. Now, for the final part of the answer, which I'm going to kind of just use this space down here, which I'm not really supposed to. In fact, what I'll do is this. I will just move this down here. That's enough space. So I have basically found the solutions that 2 theta equals minus 0.64350 and also minus 2.49809, and also it's equal to pi over 6, and also it's equal to 5 pi over 6. So I've found 4 solutions. So theta is going to be a half of all of these. So I take these values here. I'll take this one and divide it by 2. And that will give me minus 1.2490. So I'll write this to 3SF now. That's minus 1.25. Minus 1.25. That's one of them. This one, I've got to divide this one by 2. So I have negative 0.64350. Oops. I have minus 0.64350 divided by 2. And that gives me minus 0.322. Yep. And then I have pi over 6 divided by 2. If I divide this by 2, it's like multiplying by a half. It's going to be pi over 12. And this would be 5 pi over 12. And those are my values for theta. I've written down the ones that are appropriate to be given to 3SF in 3SF, and the ones that are not appropriate to give in 3SF, which you can get things in terms of pi, and I have solved this question. Okay, I hope that was clear and understandable. Other questions from this topic of trig identities and trig equations from P3 will be found in this playlist down here. Up here we'll find other questions from this P3 paper in this playlist over here. You can subscribe to my channel by clicking on this link, and on the top of the page you'll find a link to some other P3 paper you might want to watch. Thank you for watching, and I hope you understood, and see you soon.